Good evening, student. Today I will discuss about some MCQ question which are related to electric potential and capacitance. Here, my first question is: inside a hollow charged spherical conductor, the potential. Option A is constant. Option B varies directly as the distance from the center. Option C varies inversely as the distance from the center. Option D varies inversely as the square of the distance from the center. Here we know that in electric potential chapter or in electric field chapter, this is the spherical conductor. Inside the spherical conductor, electric field is 0. This is inside. Electric field is 0. So, as we know, the relation between electric field intensity and potential, that means electric field equal to minus dV by dr. So, electric field intensity is 0, which is equal to minus dV by dr. That implies V equal to constant. So, inside the spherical conductor or inside the hollow charged spherical conductor, the potential is constant. So, my first option is correct. Is constant. Inside a hollow charged spherical conductor, the potential is constant. Now, my second question is: here, a hollow metal sphere of radius 5 cm is charged such that the potential on its surface is 10 volts. A hollow metal sphere. This is the hollow metal sphere, okay, whose radius is 5 cm, okay, from the center to the surface of that sphere. The potential on its surface. So this is the surface of that sphere whose potential V equal to 5 cm. Sorry, 10 volts. 10 volts. The potential at the center of the sphere. So potential at the center of the sphere. We know potential on the surface. We know potential on the surface, which is equal to potential on the inside the center of the sphere. Inside the center of the sphere, okay, are equal. That's why from that question the potential on the surface of that sphere is 10 volts, so which is equal to potential at the center. That means potential at the center is given by 10 volts. So my option second one is correct, that is 10 volts. Okay. Now my third question is: here, a large insulated sphere of radius r. This is the large insulated sphere of radius r. This is large insulated sphere whose radius is r with q units. Our charge kete q of electricity is placed in contact with a small insulated uncharged sphere. तो ता पाखरे कोन अछि उडे uncharged sphere अछि, uncharged sphere whose radius is r prime, that bigger sphere which is contact with uncharged sphere, this is the contact with uncharged sphere by providing electricity, okay, and is then separated. ଯେତେବେଳେ bigger sphere electricity uncharged sphere को provide करूची, तापर से कोन होची according to question से separate ही जाउची. The charge on the smaller sphere will be now. तापर पचारसी smaller sphere रे केते amount of charge generate हिची. Okay, so here whenever the charged sphere in contact with the uncharged sphere, so that the bigger charge which deliver charge toward the uncharged sphere so that they balance their potential in between them. Suppose huge amount of potential which will be stored by that charged sphere, while that charged sphere which is contact with that uncharged sphere, in order to balance their potential in between them, so it deliver charge from bigger sphere to smaller sphere. That means after that it becomes separated according to question. Here that becomes separated. Okay, here in that bigger sphere, how much amount of charge become there? That is q minus q is there. But in smaller sphere, that is q amount of charge is there. That is smaller q amount of charge is here. Okay. So as we know that electric potential due to a point charge, electric potential due to a point charge V equal to 1 by 4 pi epsilon 0 q by r. For bigger sphere, it can be represented as a q minus q. For smaller sphere, it can be represented as 1 by 4 pi epsilon naught q by r prime. Here, whose radius is r, but their radius is r prime. So, here after separated, their potential becomes balanced. So, bigger sphere whose potential which is equal to smaller sphere whose potential. So here in that thing, that means 1 by 4 pi epsilon 0 q minus q by r equal to 1 by 4 pi epsilon naught q by r prime is here. So 1 by 4 pi epsilon 0, 1 by 4 pi epsilon 0 cancel out each other. Here, while we cross multiplying both of the things, so q minus q by r equal to q by r prime is here. So cross multiplying we get, so q r prime minus q r prime equal to q r. That implies q r prime equal to q r minus q r prime. So here q r prime equal to, if we q taken common, so q r minus r prime is here. That implies smaller q equal to how much amount of that? That means q r prime divided by r minus r prime is here. So how much amount of charge which will be stored in the smaller sphere? That is q equal to capital Q r prime divided by r minus r prime. Which option is correct? That means this one is, that the third option is correct, that is qr by r prime plus r. Okay. Now my next question is, here in that question, potential energy of two equal negative point charges 2 microcoulomb had 1 meter apart in air. Here this is the two negative point charges. This is the 2 point charges. The charges are here, that is negative 2 microcoulomb, and this one is also 2 microcoulomb, minus 2 microcoulomb. Both are situated at a distance of 1 meter apart in between them. Therefore, what is the potential energy in between them? Potential energy U equal to K into Q1, Q2 by R. That means 1 by Q means 1 by 4 pi epsilon 0, 1 by 4 pi epsilon 0, Q1, Q2 by R. Here in that question, 1 by 4 pi epsilon 0 means 9 into 10 to power 9. Q1, Q2 means Q1 and Q2 both are equal charges, that is about minus 2 microcoulomb into 10 to power minus 6 into minus 2 into 10 to power minus 6. Okay. Divided by R is 1 meter. So here 9 into 10 to power 9 into 2 2s are 4 into 10 to power what? Minus 12. So that means 9 4 are 36 into 10 to power minus 3 is here. So 10 to power minus 3 means, that means 0.036 joule. 0.036 joule. So this is the answer of that given question. Here option 4 is correct. That means option D, that means 0.036 joule is here. Now my next question. Here from figure shows two parallel surfaces A and B. So this one is the parallel surface A and this one is the parallel surface B. At the same potential, both are having same potential, kept at a small distance r. Both are situated at a distance r from each other according to that question. A point charge Q. Here there is a charge which is obtained from A, is taken from the surface A to B. Now that point A which delivers charge from A to B, then how much amount of work is done? पचारछि से कोन पचारछि जदी गोटे फिगर देछि क्वेश्चन रे तीटा पैरेलल प्लेट अछि प्रथम प्लेट हला A सेकंड प्लेट हला B both are situated at a distance r each other. A point which deliver charge from A to B, then how much amount of work is done? You know electric potential, you know potential difference means what? The potential difference is defined as the work done bringing a charge from particular point to particular point. That means particular point means what? Which position to which position? That means A to B here in that question. Okay, so as we know that work done equal to Q into V from which potential to which plate to which plate, that charges become travel from A to B. Okay, so W equal to, that means charge into final potential minus initial potential, that means VB minus VA. Okay, you know already in electric potential chapters what in by potential difference. Potential difference is the difference in potential where work done to bring a charge from point A to point B. Okay, so W equal to Q into VB minus VA. Here in that question, what will happen? A and B at the same potential. That means plate A having same potential as well as plate B having same potential. That means W equal to Q into VB जगह कौन पड़ेगा? VA minus VB. Okay, VB means VA. So VB means VA and VA को VA हम रख दो. That means what? According to question, VB VA equal to VB. So that implies W equal to what? Q into, that means cancel out, that is 0. That means W equal to 0. So work done is 0 while the charge moves from A to B. In order to the two plates having same potential. Now my option D is correct answer. That is 0. Okay, that is 0 is the correct answer. Okay, now my next question. In that question, the potential function of an electrostatic field is given by V equal to x square. Given V equal to how much? 2x square. Determine the electric field strength at point 2 meter 0 3 meter. Here electric field strength at point क्या दीजिए 2 meter, 0, 3 meter. This is the point. We know the relation E equal to minus dV by dr. Okay, E equal to what? Minus dV by dr. The dr can be represented as dx. So minus dV by dx is here. Okay, here in that given question that given v equal to x square, there is no y and z term is here, so only x term is here. So e equal to minus d by dx of v means what? 2x square. So 2 is a constant quantity and x is the variable, so that constant quantity taken outside now differentiate with respect to x, that is x square which is differentiable with respect to x. So its value can be represented as minus 2 into 2x. Again dx by dx is here. So dx cancel out. How much is here? Electric field equal to minus 4x. So electric field is equal to minus 4x is here. Okay, electric field is equal to minus 4x is here. But here electric field along x direction, it is given as what? That is 2 meter. Electric field along x direction, electric field along x direction is 2 meter. That means if you put the value along x direction and it is donated by I cap, so electric field vector equal to minus 4, x means how much? Into 2. Along which direction? That is along x direction, that is given as I cap direction. I cap is the direction, unit cap, which provide its direction. So that means electric field equal to minus 8 I cap. Okay, but there is no y direction and z direction is here. That means electric field that is along x direction. So electric field along y direction is 0 and electric field along z direction is 0. That means electric field and along x direction is what? That is minus 8 I cap. Here my option D is correct answer. Option D is correct answer, that is electric field along x direction is minus 8 I cap. Newton per coulomb. Okay, how much? Newton per coulomb. Okay, now my next question is here. In that question, the electric field in a region surrounding the origin is uniform. So this is the electric field intensity there becomes uniform. Okay, along when you use the direction, that is along x direction. So this is the x-axis, you have to notify that thing. That means along x direction electric fields are moving, there becomes uniform. A small circle is drawn with the center. So आमे कौन करछे ए इलेक्ट्रिक फील्ड रो डायरेक्शन रे आमे कौन करछे गोटे यूनिफॉर्म स्मॉल सर्कल को आमे ड्रॉ करछे. Okay, according to question, a small circle is drawn with the center. This is the center and this is the circle whose center is this one. Okay, at the origin cutting the axis. Sure, origin de kon jaଉଛି ଗୋଟେ axis pass is at point A B C D. This one is A B C D. Coordinates are minus a comma 0. This is the point O, that is the 0 origin. Origin means reference point whose value is 0 comma 0, and that can be represented as minus a comma 0 is here according to that question. And this one is 0 comma minus a, 0 comma minus a, this one 0 comma minus a, and that represents a comma 0. So that is 0 and that is a, so a comma 0, and that represents 0 comma a. 0 comma a is here respectively as shown in figure. Then the potential is minimum at in which position? से पचारछि को पोजीशन रे तमर पोटेंशियल टा मिनिमम रहइबो. तो पहिले हमें क्वेश्चन को बुझु से कोन इलेक्ट्रिक फील्ड गोटे x डायरेक्शन रे यूनिफॉर्मली मोशन करछि. से भीतर गोटे सर्कल रिप्रेजेंट कराइछि. से सर्कल रो सेंटर होछि दिस वन जे कि एक्सिस ऊपर अवस्थान करछि, जदरे कि गोटे सर्कल रे चारिटा पॉइंट दिया हिछि a b c d ताको नोटिफाई कराइछि -a, 0 0, -a, 0 and 0, a रे. तो पचारछि then the potential is minimum. सो को पोजीशन रे तमरो पोटेंशियल मिनिमम होची ताको दर्शाओ बोली कहिछि हियर ऑप्शन देछि ए पोजीशन रे मिनिमम रहउछि ना बी पोजीशन रे मिनिमम रहउछि ना सी पोजीशन रे मिनिमम रहउछि ना डी पोजीशन रे मिनिमम रहउछि जोटा कि हम फाइंड आउट करिबा तो आमे जानछि बोले द रिलेशन इलेक्ट्रिक फील्ड एंड पोटेंशियल E इक्वल कोन माइनस dV by dr is here. So electric field and potential gradient both are related to each other, but a negative sign is here. In particular direction, electric field moving, that is along x-axis. Here, along the x-axis, electric field is moving, but potential, which is negative of electric field. So, जो direction तमर electric field अछि, तो आमे ए जिंस रो आमे भाबी परिबा, तो कोन हबो potential becomes maximum at opposite to that electric field. So that means VA is greater than that of V. What? C. That means VC potential at C position is minimum as compared to potential at A position. आमे जदि consider करिबा तारथो से पचारछि को पोजीशन तमरो पोटेंशियल मिनिमम रहइबो ऑब्वियसली सी पॉइंट रे तमरो पोटेंशियल मिनिमम रहइबो दैट इज ऑप्शन सी इज करेक्ट दैट मींस potential at C position is minimum. Okay, so potential is minimum at point C. Okay, so this is the 7th number question. Now my next question is here three charges 2q minus q and minus q are located at the vertices of an equilateral triangle. Here this is the equilateral triangle means sambahu tribhuj. Here three charges are there, that is 2q minus q and minus q are there on the three vertices at point A, B and C. Okay, so बच्चा से at the center of the triangle, center है कौन होगा? This is the center of the triangle. So option A is the field is 0 but potential is non-zero. Second option is the field is non-zero but potential is 0. Third option means both field and potential are 0. Fourth option माने कौन देछि both field and potential are non-zero. तो हम फाइंड आउट कर बोलछि पोटेंशियल आउ फील्ड 0 होछि ना नॉन 0 होछि तो फिर प्रथम हमें फाइंड आउट करिबा पोटेंशियल को यू नो पोटेंशियल इज अ स्केलर क्वांटिटी सो इट हैज नो डायरेक्शन दैट्स व्हाई हम जान छ कोन हियर इफ यू ड्रॉ फ्रॉम दैट पॉइंट दैट इज द सेंटर ऑफ दैट triangle is given by now you join the center of the triangle and that vertices. These are the vertices and these are the this is the center. If you draw that line from the vertices to center, here that distance is given by the sides are three sides, so it can be represented as what? A by root 3. A by root 3. Okay, this one is A by root 3, this one is A by root 3 and this one is A by root 3. Okay, but this one is A by root 3 is here. So now we have to find out what? This is the electric potential at that point. Here electric potential at that point due to point A. So we know the potential at a particular point due to point charge. I mean and check on formula specially 1 by 4 pi epsilon 0 q by r. So 1 by 4 pi epsilon 0 को मु डोनेट करली point A पाई VA इक्वल लिख देली k q by r. Here q माने केते q means 82q, r means what? That is A by root 3. That means A by root 3 is here. Okay, similarly potential at B, how much? That means k into q means what? Minus q is here and A means what? That is A by root 3. Similarly potential at C, potential at point center due to point C, what? That means what? What? That is equal to minus q, k into minus q divided by A by root 3 is here. So if you adding all these quantities, because potential is a scalar quantity, so VA plus VB plus VC equal to what? V, net potential. That means K 2Q by A by root 3 minus that minus plus minus minus K Q by A by root 3 minus K Q by A by root 3. That means that is 2Q A by root 3 here, Q by A by root 3, Q by A root 3. That means 2Q A by root 3, that is KK is here. So all are cancel out each other. That means potential at the center is 0. So in that figure, which options are there? 0, that is potential is 0 is here. The potential is 0 is here. From above 4 options, 2 options are there, but 2 options are incorrect. Now we'll find which one is the actual option. Okay, B and C are there. Both options potential is 0. But we have to find out the electric field intensity. Here, electric field intensity. How to calculate electric field intensity? So, electric field intensity is a vector quantity. That's why it has some direction. If the directions are there cancel out, then it becomes 0. So, electric potential at that point due to first 2 Q charge. So, its direction like as in that direction. That means this is the first Q charge, 2 Q charge spine ketas na. That means electric field intensity due to this direction. And for point B, electric field intensity is given by its direction moves towards the minus Q charge, that is in that direction. And this is also minus Q charge here, so it attracts towards the minus Q. That means the direction which is provided toward the minus Q, and this is also minus Q. Here, 3 directions are in same side. That means at the center we have to obtain the non-zero value of that electric field is 0. हमें फाइंड करिया आवश्यकता नहीं कौन देखले डायरेक्शन देखले तीनटा डायरेक्शन जा कौन अछन सेम डायरेक्शन अछन. That's why there is some value is obtained. Whose value? That is electric field intensity, whose value is obtained at that center because it provides some direction. They are not cancel out. That's why it has some directions are there. Due to some direction, it has non-zero value of electric field intensity. Here option, that means potential is 0, but electric field is non-zero. That means option B is correct answer. So the field is non-zero, but potential is 0. Now my next question, that is 9th number question. Okay. Here that question which is based on the capacitor. Okay. The capacitor each of capacitance 1 microfarad are connected in parallel. So this is the capacitor number 1 and this is the capacitor number 2. Both are connected in parallel. Clear? Each having capacitance, that is 1 microfarad, 1 microfarad. Okay. Then they are charged by 200 voltage DC. एमानु चार्ज कराइछ काहे रे 200 volt DC रे चार्ज कराइछ. 200 DC supply volt DC. So पचारछि how much amount of energy stored by that system? A system केते store करिवो energy. So हमें जानिछे पहिले you know capacitor they are connected in series. के कहि परिबो capacitor they are connected in series, that means 1 by what? That is C1 C2 divided by C1 plus C2. But Cp, that means capacitor connected in parallel, is given by C1 plus C2, which is opposite to resistance. Okay, in series connection as well as parallel connection. Now in that question, both the capacitor they are connected in parallel. That's why here we have to put the formula like as the capacitance in parallel, that is C1 plus C2 is here. So here two capacitors each are having capacitance C1 equal to 1 microfarad and C2 also 1 microfarad. So net capacitance, that means C net in parallel connection, which is equal to C1 plus C2 is here, that is 1 plus 1, that is 2 microfarad is here. Okay, unit volume pile. Okay, now that is the net capacitance. That net capacitance which is connected to 200 voltage DC. So energy stored in a capacitor is given by ଆମେ ଜାଣିଛେ half C V square. So half ରହିଲା C means what? C net means 2 into microfarad means 10 to power minus 6. Micro means 10 to power minus 6. Milli means 10 to power minus 3. Pico means 10 to power minus 12. Nano means 10 to power minus 9. Okay. Mega means 10 to power 6. Okay. Kilo means 10 to power 3. Okay. Here 2 into 10 to power minus 6 into V means what? V square. V square means 200 into 200. 200 into 200 is here. So here 2 cancel out. Here 10 to power 6 minus 6 into 4 into 10 to power 4 is here. So 10 to power minus 6, 10 to power 4 cancel out. So that means 4 into 10 to power minus 2 is here. 4 into 10 to power minus 2 is here. That means which option is correct? That means in the form of point. So here that means 0.04 joule is here. Now my option C is correct answer. Okay. You have to understood that thing. Option C is correct. That is 0.04 joule. Clear? Now my next question is, here in that question, capacitance 0.3 microfarad and 0.6 microfarad respectively are connected in series. Here this is capacitor number 1 whose capacitance is 0.03 microfarad, and second capacitor 0.66 microfarad. Both are connected in series. The combination is connected across the potential difference of 6 volts. A connection is a potential difference 6 volt, battery द्वारा connection is 6 volts. Okay. The ratio of energy will be, that means पचर्ची E1 by E2 केते will पचर्ची. How much? So how to calculate pile? So pile first the two capacitors they are connected in series. Here now we have to calculate the net capacitance of that capacitor. So that means here C1 is what? That means here in that question C1 equal to 0.3 microfarad, C2 equal to 0.6 microfarad, and V equal to how much? V equal to 6 volts. Okay. So the net capacitance of the capacitor they are connected in series, that is CS, that is C net capacitance C net in series connection equal to what? C1 C2 divided by C1 plus C2. That means C1 means 0.3 into 0.6 divided by 0.3 plus 0.6. So equal to what? That is 1.8 divided by 0.9, that is equal to how much? That means 0.2 microfarad. So net capacitance of the capacitor equal to 0.2 microfarad. So here in that capacitor, in that two capacitor they are connected in series, so net capacitance is 0.2 microfarad. Now we have to calculate the how much amount of charge which is carried by the capacitor. That means Q equal to here Q equal to CV. That means C means net, C net into that C net is connected to battery, that is 6 volt battery. So here Q equal to C net means 0.2 into V means what? That is 6 volts. That means how much? That means 1.2 microcoulomb. Its unit is coulomb, so its value is Q equal to how much? That is 1.2 microcoulomb. As we know that the two capacitors are connected in series, then that 6 volt battery is sending current in the form of charges. So both each capacitor carry same amount of charges, that carry 1.2 microcoulomb and that also carry 1.2 microcoulomb because they are connected in series. You know that in series connection current remains same. So current means the number of flow of electrons or flow of charges called current. So in both of the capacitor current remains same, that's why charges remain same. Okay. So now we have to calculate the potential difference across the two capacitors. Each capacitor we have to calculate the potential difference. So here in capacitor 1, the potential difference across capacitor 1, that is V1, equal to what? V equal to what? C equal to Q by V, V equal to what? Q by C. Okay, C means what? Q by C1. Okay, so Q means what? That is 1.2 divided by C1 means that is 0.3. That is equal to 4 volts. Okay, similarly V2 equal to Q by C2. So Q means what? 1.2 divided by 0.6, that is equal to 2 volts. So one is V1 equal to potential difference across capacitor 1 is 4 volts, 4 volt, and this one is 2 volts. Okay, so if you adding both of these things, then you will get 6 volts. So our answer is correct. So V1 and V2 is there. So now we have to find the energy stored in the capacitor 1. So E1 equal to half C V square. So C means C1 and V means V1 square. So half is here. C1 means what? That is 0.3 into V1 means, that means 4 into 4, that is V1. So this one, so 2 cancel out. So here that means 8 into 0.3, that means 2.4 joule. Similarly E2 equal to half C2 V2 square, that means half C2 means 0.6 into what? Into V means what? That means 2 volts. 2 into 2. So 2 cancel out. So what will happen? That means what? That is 1.2 joule. Now we'll find out the ratio of that two capacitor, the energy stored in the two capacitor, the ratio E1 by E2 equal to what? That means E1 is 2.4 and E2 is 1.2, so their ratio is 2. So here that option B is correct answer. Option B is correct answer. Okay. Now my next question. Here the equivalent capacitance of the parallel combination of two capacitor is 4 times their equivalent capacitance when connected in series. This means that the equivalent capacitance of the parallel combination of two capacitor is 4 times. Suppose this is capacitance of the series connection CS and this is CP. Here according to question, CP is 4 times than that of CS. That means if you assume CP that is 4, then CS is 1. Then this means that option A, their capacitance are equal. Their capacitance are 2 microfarad and 4 microfarad. Their capacitance are 0.5 microfarad and 1.0 microfarad, and last option is none of these. Here if we assume C is given by 2 microfarad. Okay, so we have to assume that C equal to 2 microfarad. Then in series connection CS net capacitance is given by C1 C2 divided by C1 plus C2 is here. C1 C2 means what? 2 into 2 divided by 2 plus 2, that means equal to 4 by 4, that is equal to 1 microfarad. So in CP connection what will happen? CP equal to C1 plus C2 is here. C1 means 2 microfarad plus C2 equal to 2 microfarad. So 2 to 4 microfarad. So here in above question, if we assume C is 2 microfarad, then net capacitance in series connection is 1, and in parallel connection the net capacitance is 4 microfarad. So here our question related to that 2 points. Here capacitance is 4 times, then capacitance in parallel connection 4 times than that of capacitance in series connection. That means Hence our option, the capacitance are equal, that option becomes correct. Their capacitance are 2 microfarad and 4 microfarad, that not be a correct answer. Their capacitance are 0.5 microfarad, 1 microfarad, that not be a correct answer. None of this, that is also not a correct answer. That means capacitance in parallel connection is 4 times as compared to capacitance in series connection. So hence their capacitance are equal, because if we assume C equal to 2 microfarad, in both of the cases 2 microfarad is here, so they contain the form that question. Okay, so their capacitance are equal. Now my next question is, here in question number 12, 3 capacitor of capacitance 3 microfarad, 9 microfarad and 18 microfarad are connected once in series. So this is the capacitor 1, capacitor 2, capacitor 3. They are connected in series. Okay, they are connected in series, whose capacitance 3 microfarad, C1, C2, C3, 3 microfarad, 9 microfarad and 18 microfarad. Clear? They are connected in series and another times in parallel. प्रथम series connection होचन, तापर कोन होचन parallel connection होच. The ratio of equivalent capacitance in two cases will be बोली पचारला. तार्थ CS by CP करो बोली कहिछि. तार्थ capacitance, the net capacitance in series connection equal to कोन, that means आमे जानि जे 1 by C equal to C net equal to 1 by C1 plus 1 by C2 plus 1 by C3 in series connection. So 1 by C1 means 1 by 3 plus 1 by 9 plus 1 by 18. So our LCM is 18. 18 3 is 6. 6 into 1 6. 9 18, that is 2. 2 plus what? 3 18. 18 18 is 1. That is 1. That is 8 plus 9. 9 by 18, that is 9 by 18, that is 1 by 2. That means 1 by C net equal to 1 by 2. That implies C net equal to 2. In series connection, C net equal to what? That is C net in series connection equal to 2. So now in parallel connection, in parallel, Cp equal to C net for parallel connection equal to C1 plus C2 plus C3. That means C1 means 3 plus 9 plus 18. 9 plus 3, that is 12. 12 plus 18 is 30. That is 30. Okay, that is 30 microfarad and this one is 2 microfarad. So the ratio of equivalent capacitance. So ratio means CS by CP. According to question, the ratio of equivalent capacitance, that is the net capacitance in series connection divided by net capacitance in parallel connection, that is 2 by 30 equal to what? That is 1 by 15. So 1 by 15, that is our answer is 1:15. 1:15, that is the first option is correct. 1:15 is our answer, that is the first option, 1:15. Okay. Now my next question is, here in question number 13, a capacitor of 2 microfarad charged to 500 volt is connected in parallel with another capacitor of 10 microfarad capacitance and charged 200 volts. Suppose this is the capacitor number 1, whose capacitance C1 equal to 20 microfarad and charged is V1 equal to 500 volts, is connected to in parallel, connected in parallel. कहाँ connection is parallel connection is capacitor number 2, C2, whose capacitance is 10 microfarad and charged to 200 volts. So V2 equal to 200 volts. So then the common potential is, so emananकर कोन common potential केते बोली पचारछ. So here in that question, this is the common potential is very very important, and that common potential whose formula is given by common potential, which is equal to sum of total charges divided by sum of capacitance. Please note it. This is the very important formula for your exam. So common potential equal to sum of total charges divided by sum of capacitance. Here sum of total charges, how much capacitance are there? Two capacitors are there. So they contain two charges, Q1 plus Q2 divided by how many capacitors are there? That is 2. Their capacitance C1 plus C2. Clear? So Q1 plus Q2. Now we will find out the value of Q1. So Q1 equal to C1 into V1. C1 means 20 into 500. That means what? 10,000 what? Micro coulomb. Okay. Similarly, Q2 equal to C2 V2. C2 V2 means what? C2 equal to 10 into 20. That means what? 10 into 200. That means 2000. So that is 10,000 microcoulomb, and this one is 2000 microcoulomb. If you put the value in common potential, Cp equal to common potential equal to Q1 means what? Q1 means that is 10,000 plus Q2 means what? That means 2000 divided by how much capacitance are there? That is 220 plus 10 microfarad. So that means that is what? That means 10,000, 2000 means 12,000. Here we note that thing, that is equal to how much is here? That means Cp equal to 12,000 divided by 30. So 0 cancel out, and 3 4 that is 400. So Cp equal to common potential equal to 400 volts. So here option C is correct answer. Here common potential is given by 400 volt. That is option C is correct answer. Okay, note it. Please note it. And this is the very very important for your exam. Now my next question is, here in question number 14, a capacitor of 1 microfarad charged to 50 volts. A capacitor of 1 microfarad. This is the capacitor of 1 microfarad charged to V equal to what? That is 50 volts. Okay. It is now connected to an uncharged capacitor. Now that becomes connected to an uncharged capacitor whose capacitance is C2 equal to 4 microfarad. Then how much its common potential is? So semananकर कोन common potential केते बोली पचाछि. You know, in before question I have discussed, that is common potential equal to sum of total charges divided by what? Sum of total capacitance. So sum of total charges means Q1 plus Q2 divided by C1 plus C2, that is equal to Cp. Here in that question C1 V1 is there, so Q1 equal to C1 into V1, that means 1 into 50, that means 50 microcoulomb is here. But capacitor 2 which is uncharged, that means there is no potential across that capacitor, that's why there is no charge is here, that means Q2 equal to 0. So if you put the value Q1 and Q2 in that equation, so Cp equal to how much? So Cp equal to Q1 plus Q1 means that is 50 microcoulomb plus Q2 means 0 divided by C1 means that means 1 plus C2 means 4, that means Cp equal to common potential equal to 50 microcoulomb divided by 5 microfarad, this one microfarad. So that means 5 tens are, that is equal to 10 what? Volts. So 10 volt. Option D is correct answer. Option D is correct answer, that is common potential is 10 volts. Okay. Now my next question is, that is 15 number question. In 15 number question, the plate of a charged parallel plate capacitor are pulled apart. Now, potential difference will remains unchanged, potential difference will decreases, potential difference will increase, the capacitance will increase. Here in that question again I repeat, the plates of charged parallel plate capacitor are pulled apart. That means this is the capacitor whose plates are oppositely pulled, that means pulled apart. That means this is the capacitor, the distance becomes increases. This is the thickness D and this is the large distance in between the two plates. The distance between the two plates becomes increases, then we know the formula C equal to epsilon 0 A by D. So D becomes increases, then C becomes what? C is directly proportional to 1 by D. If D becomes increases, then C becomes decreases. As you know that C equal to, so here in option cases the capacitance will increases, but here in that case capacitance become decreases, so that option is not there, not correct. So again we know C equal to Q by V. If C becomes decreases and V becomes increases, so in that formula, so V will becomes increases, that means potential difference will increase. That option 3 is correct, that means option C is correct answer. Potential difference will increase. Okay, that means C directly proportional to 1 by V, that means C becomes decreases, V becomes increases, that means option C is correct answer. Okay, now my next question is, now in that question, that is 16 number question, 5 equal capacitors in series have a resultant capacitance of 4 microfarad. That means, so there is the 5 capacitors, they are connected in series, 2, 3, 4, 5. 5 capacitors are connected series. So net capacitance, that is C net capacitance, which is equal to that means 4 microfarad. Okay, so C net means what? That means 1 by Cs equal to 1 by C1 plus 1 by C2 plus 1 by C3 plus 1 by C4 plus 1 by C5 equal to what? That is 4 microfarad. That is the net capacitance value. So 1 by Cs means this one. So that is if you LCM, taking LCM, that C1, C2, C3, that is the 5 capacitors. So C1 equal C2 equal C3 equal C4 equal C5, that means that is equal to C. If you represent C value, that means 1 by Cs equal to what? That is C by 5. 1 by Cs equal to, that means Cs equal to what? that is C by 5. That means CS is given by what? That is CS means CS is 4 microfarad. That means CS is 4 microfarad, that's value is C by 5. That implies capacitance. Each capacitor whose capacitance is given by C equal to 4 into 5, that is 20 microfarad. That's how it देखिले जदि 5टा कैपेसिटर को हम जदि सीरीज रे कनेक्शन करछे तार नेट कैपेसिटेंस जदि 4 माइक्रोफैराड हुए ताहले इच कैपेसिटर रो कैपेसिटेंस केता हबो C equal to 20 microfarad हबो. So here from that question 5 equal capacitor are connected in series have a resultant capacitance of 4 microfarad, that is 4 microfarad. When these capacitors are connected in parallel, now एबे हम कोन करिबा each capacitor को हम कोन करिबा parallel connection करिबा. C1, that is C, and this one is C. They are connected in parallel. Okay, they are connected in parallel. That is the 5 cables C. So they are connected in parallel. The net capacitance becomes C net for parallel connection, that is equal to C1 plus C2 plus C3 plus C4 plus C5. We know each capacitor whose capacitance is 20 microfarad, then 5 capacitors, they are connected in parallel, so its value is N into C. N means how many capacitor, that is 5 capacitance. Each capacitance whose capacitor whose capacitance is 20 microfarad, that is equal to 20, that is 100 microfarad. So the net capacitance while the 5 capacitors are connected in parallel whose capacitance is given by 100 microfarad. Now here they are connected in parallel and charged to 400 volts. तो एक कैपेसिटर को कौन करा होची चार्ज करा होची केते रे 400 volts. That means V equal to 400. Then we'll find out the total energy stored. So how much stored by the capacitor when they are connected in parallel? That means we know the formula E equal to half CV square. So that means half. C means what? That is 100. V means what? V means what? That is what? That is 400 volts. So this is 400 volts. That is 400 into 400. And that can be represented 100 into 10 to power minus 6. 100 into 10 to power minus 6 is here because microfarad is here. In SI, it can be represented as 100 into 10 to power minus 6 farad. So if you cancel, that is 250 or 100 or 100,000, that is 2 2 4. So here that is 8 into 10 to power 4. 10 to power 4, this one 2, 2, 4, this one 2. That is 10 to power 6. 10 to power 6 into 10 to power minus 6. So equal to E. Equal to 10 to power 6, 10 to power minus 6 cancel out. That means E equal to how much? That is 8 joule. So our option B is correct answer. That is 8 joule. Okay. So first of all the capacitors are connected in series. So net capacitance already provided by the question, that is 4 microfarad. So capacitor whose capacitance is 20 microfarad. Now that capacitor are connected in parallel whose capacitance is 100 microfarad. Then you know in question the potential across that capacitor is 400 volts. Then we will get the total energy stored is given by E equal to half CV square. So E equal to how much? That is 8 joule. So option B is the correct answer. So this is all about some MCQ parts I have discussed in the chapter like as electric potential and capacitance. Thank you to all.